There's a strange comfort in patterns. We find them in the drift of clouds, in the rhythm of oceans, in the quiet movement of planets that circle through eternity. But sometimes a pattern can whisper something different, something deliberate. For years, astronomers have watched the stars for travelers that don't belong to our system. First, there was Oumuamua, a cigar-shaped visitor tumbling through the dark. Then came 2I Borisov, a frozen wanderer born beyond our sun. Now we have another, 3I Atlas. Before we begin, let your mind slow down. The noise of the day can fade now. You're safe here, just drifting among ideas and stars. Let every breath guide you deeper into stillness. Welcome to Science Reshaped, a calm corner of the cosmos where we wander through science like dreamers tracing constellations in thought. Before we continue, please subscribe to the channel and tell us where you're listening from. It's always humbling to imagine how many tiny lights on this planet are sharing the same moment of wonder. Now, let's begin. It slipped into our cosmic neighborhood almost unnoticed. No flash, no fanfare, just a faint trace, first spotted by the Atlas survey, a system meant to warn us of asteroids that come too close. Yet what it found was something older, colder, and far more curious. Its path was unlike any comets we've known, retrograde, traveling against the normal flow of our solar system, tilted at an odd angle, about 5 degrees off the ecliptic. Its orbit stretched backward through space, as if it came from a different rulebook altogether. The calculations told a simple truth. 3I. Atlas wasn't born here. It came from somewhere beyond our sun's family, an interstellar wanderer, a piece of another world's history now passing through ours. At first, astronomers thought it would simply swing past, dip close to the sun, and leave forever. But as its trajectory was refined, something subtle began to emerge, a geometry so quiet that at first no one paid attention. When mapped in 3 dimensions, its path brushed against Mars, then skimmed the inner orbit near Venus, and finally crossed a region linked with Jupiter's gravitational reach. 3 worlds, 3 chances for observation, almost as if it were sampling them. Coincidence, maybe. But even coincidences in space can tell stories. And this one, the way it threads past these planets, feels almost too precise. Tonight, as we drift deeper into this mystery, we'll follow that line, through orbits, chemistry, and possibility, to ask a question that science rarely allows itself to ask. What if 3I Atlas isn't just wandering? What if it's looking? For most of the scientific community, 3I Atlas was just another statistical addition to the growing list of interstellar objects. But for a handful of astronomers, something about it didn't sit right. It wasn't just where it came from, it was where it was going. When its orbital elements were plotted, they drew a strange, deliberate thread through our solar system. The trajectory wasn't random. Its path moved inward, crossing the outer orbit of Mars, sweeping close to Venus, then bending out again toward the gravitational boundary of Jupiter. On a flat map, it looked ordinary enough, a long looping curve, a comet's dance with sunlight. But in 3-dimensional space, that curve became something else. It became geometry. Clean, quiet geometry that linked 3 planets in sequence. Not in chaos, not in coincidence, but in a line. At first, it was dismissed as numerical noise. But as refinements came in, as data sharpened, the same pattern held true. The object passed the orbital plane of Mars, then threaded inward, dipping closer toward the inner system before grazing the region of Venus. And when it departed, it moved directly through a zone that connected with Jupiter's influence. A perfect corridor, framed by worlds that define the conditions for life as we know it. Mars, where life might have ended. Venus, where it might have failed. Jupiter, whose gravity shields life from destruction. 3 planets, 3 moments in evolution's story, and 1 visitor that quietly traced them all. The odds of this alignment were staggering. Statistical modeling placed them below 0.5%, a margin so thin it begged the question, how? Why would an object, born beyond the reach of our sun, thread through this narrow passage? It wasn't just any route through the solar system. It was the one path that brushed past every world that could speak to the origins, failures, and preservation of life. Some scientists said it was pure coincidence, a meaningless arc carved by celestial dynamics. But others, those who had seen too many coincidences behave like fingerprints, began to wonder if this was something more. When you zoom out far enough, patterns emerge that no single observation can explain. And when you trace the line of 3I Atlas from its entry to its eventual departure, what you see is not chaos. You see design, or at least something that behaves like it. Its velocity vector cut across the ecliptic at an inclination of about 5 degrees. Its approach was retrograde, meaning it moved against the usual planetary flow, and that made the precision of its encounters even stranger, like a thread woven backward through a tapestry that had already been completed. The more astronomers mapped it, the quieter the room became. What they were looking at wasn't just an orbit, it was choreography. Every parameter, from its perihelion distance to its exit angle, fit into a sequence that echoed deliberate sampling, as though the object were, in some way, collecting. Passing by Mars to taste the traces of its atmosphere, near Venus to study its carbon-heavy clouds, near Jupiter to measure the radiation belts that define the outer edge of habitability. No one would say it aloud, not yet, but the thought was there, whispered through long nights in observatories and quiet Slack channels between researchers. What if it wasn't a coincidence? What if we were being measured in return? The solar system is vast, coincidences happen, but this was geometry that stared back. By the time most telescopes caught its movement, 3I Atlas was already deep within the inner solar system. Drifting silently between invisible boundaries we had only begun to understand. The software kept plotting, the coordinates updated hour by hour, and yet every new calculation seemed to tighten the same invisible thread. Each update pulled the curve sharper, cleaner, closer to something that looked and felt deliberate. It didn't just cross planetary orbits, it brushed them in sequence, with unnerving precision, like a machine tracing a known path through checkpoints it somehow remembered. When projected against the sun's gravitational field, the route unfolded like a ribbon coiling through the dark, bending smoothly through gravitational harmonics that would take years for even our fastest probes to map so efficiently. At first, it was easy to explain away. A random inclination, a captured interstellar body caught in a convenient dance of chance. But numbers have a way of refusing comfort. The deeper the data went, the less random it became. The orbital reconstruction showed that its closest approach to Mars wasn't just near the orbit, it passed within a range that placed it directly inside what mission engineers would call an optimal observation window, a region where sensors could sweep a planet without entering its direct gravitational influence. That's not something comets do, not exactly. Comets don't care for efficiency, they care only for motion. When its velocity vector was compared to the average inbound distribution of interstellar bodies, another oddity appeared. 3I Atlas was faster, but not recklessly so. It arrived with a deceleration curve that seemed almost moderated, like a spacecraft adjusting its approach to maintain control. No visible propulsion, of course, but the effect of control nonetheless. Then came the Venus pass. That was where attention sharpened, because Venus sits in a delicate place between heat and habitability, an echo of what Earth could become if balance ever tips. And as 3I Atlas moved toward its perihelion, its projected path intersected the zone near Venus's orbital arc at a point so near perfect it could have been drawn by an engineer's hand. A mere fraction of an astronomical unit separated the two. Close enough for observation, too far for capture. Venus had already been shining brightly in the morning sky when that data came in. A burning white disk wrapped in sulfurous clouds. If something had looked down from the surface of 3I Atlas that day, it would have seen a world cloaked in storm and acid, spinning beneath it like an experiment gone wrong. The thought lingered, not as proof, but as possibility. Was it simply that we wanted meaning in randomness? Or was this geometry whispering back? The third intersection, the Jupiter pass, made the whisper louder. By the time 3I Atlas reached the region influenced by Jupiter's gravity, the models predicted it would move through a zone that had been monitored for decades, the Trojan Fields, clusters of asteroids that follow Jupiter's orbit like a cosmic wake. Many of those bodies have long been theorized as ideal locations for monitoring the inner system, protected by Jupiter's gravity well and stable over eons. 3I Atlas drifted straight through one of them, not randomly, directly through. The alignment was so clean that when overlaid against long-term mission schematics, theoretical, purely human, It matched one of the predicted survey arcs proposed for automated outer system mapping probes. Except this was no human probe. This was something that had come from elsewhere, and when it passed through Jupiter's corridor, its brightness dipped unexpectedly. Spectrographs showed a brief change in the ratio of reflected sunlight to emitted gas. Not a large one, but measurable. For a few days, 3i Atlas seemed to change its own visibility, as if adjusting how much of itself it wanted to reveal. Then the brightness returned to normal, and it continued outward, leaving no trail but questions. Scientists stayed quiet. The data wasn't proof of anything. It could all be explained naturally. Outgassing, tumbling, fragmentation, instrumental noise. Every observation had a rational excuse, and yet the pattern refused to dissolve. 3 planetary corridors, 3 moments of precision, 3 brushstrokes across the canvas of our solar system. If you were designing a reconnaissance route, one that could observe habitability, atmosphere, and defense mechanisms, it would look remarkably similar. Mars for water and remnants of life, Venus for atmospheric chemistry and climate extremes, Jupiter for shielding, magnetism, and radiation. Even the distances seemed tuned, as if selected for balance between observation and safety. No deep dives into planetary wells, no risk of collision. A sweep through the system's most telling layers, and then an exit toward the stars. No one dared to call it artificial. That word stayed off official papers, buried in drafts and quiet discussions. But the silence that followed each new update spoke louder than any declaration could. It was the silence of people realizing they might be staring at design, wearing the mask of coincidence. At observatories from Hawaii to La Palma, the late-night shifts began taking on a new rhythm. Scientists leaned closer to screens, ran calculations twice, rechecked baselines, and still the numbers held. The geometry was real. The odds were absurd, and 3i Atlas was still moving, smooth, silent, indifferent. In the end, all that remained was the path itself, a line through 3 worlds, each telling a different story of life and failure, of what was, what is, and what might be. A single visitor tracing the sequence, like a reader skimming the pages of a history written in orbits. Some called it coincidence, others called it pattern, but the truth, the one you feel when you look long enough, is simpler and more unsettling. Whatever 3i Atlas is, it's not just passing through, it's following something, and perhaps, just perhaps, it already knows where it's going next. By the time the world began to notice 3i Atlas, its path was already written. Telescopes weren't guiding it. They were merely watching the ink dry on a cosmic signature that had been set long before we had names for the planets it brushed. The deeper scientists looked, the stranger it became, because the orbit was only the beginning. What made 3i Atlas truly unsettling wasn't just where it went, it was what it was made of. As light from the sun touched its surface, it began to release a faint coma, a halo of vaporized material that wrapped it in a ghostly veil. This is normal for a comet, but 3i Atlas's composition was anything but normal. Spectral analysis showed a chemistry that didn't match expectations. Comets born beyond our sun are usually rich in water ice, methane, and traces of ammonia. They carry the frozen fingerprints of their home systems, a kind of molecular dialect written in ice. But 3i Atlas spoke another language. Its coma was dominated by carbon dioxide, not water, 8-to-1 in favor of CO2. It wasn't just unusual, it was nearly unheard of. Even among solar system comets, that ratio was extreme, bordering on the impossible for a body that had spent eons in the frozen dark. Scientists argued endlessly. Some said it meant the object came from a system colder than ours, a place where water never condensed, leaving only carbon dioxide to form its frozen shell. Others countered that such ratios could only form through intense, selective loss, like something had burned away the lighter ice, leaving behind a sculpted remnant. But there was another possibility, one so unnerving that no one wanted to write it down. What if the ratio wasn't natural at all? What if it was chosen? Because if someone, or something, were designing a probe to travel across interstellar space, carbon dioxide ice would make a strange kind of sense. It's dense, it's thermally stable, and it sublimates in a controlled way under solar heat. It could act as both camouflage and fuel, hiding machinery beneath the guise of a comet while allowing gentle course corrections through outgassing. Of course, there was no proof of that, only the chemistry, Only the silence, and the quiet fact that the object's brightness curve didn't behave like a typical comet's. It fluctuated too smoothly, too predictably, as if its surface was being regulated, controlled, even. When the James Webb Space Telescope briefly turned its gaze toward 3I Atlas, the data returned something else. Faint but clear signatures of complex carbon compounds that didn't fit any known category. Too heavy for simple organic dust, too structured for random molecular debris. Somewhere between chemistry and engineering, the line blurred. Back on Earth, the findings didn't make headlines. They sank quietly into the databases, buried beneath cautious language. Unusual composition, non-standard outgassing behavior requires further study. But between the lines, the subtext was unmistakable. No one had ever seen anything quite like this. At the Mauna Kea observatories, a team ran simulations overnight. If 3I Atlas had originated from a natural system, it should have carried isotopic signatures typical of its environment, certain ratios of deuterium to hydrogen, specific carbon isotopes tied to formation temperatures. But the readings refused to conform. They were flat, uniform, too clean. It was as though the object had been stripped of history, like every trace of where it came from had been washed away, leaving only what it was now. One researcher, writing in an unreviewed private note later leaked online, put it more simply: 3I Atlas behaves less like a relic and more like something built to endure a journey. That thought, once planted, refused to die. If that were true, then the carbon dioxide wasn't an accident. It was a design feature, an interstellar disguise that could survive radiation, heat, and centuries of drift, shedding just enough mass to look convincingly natural while maintaining internal stability. A traveler that could hide in plain sight, wearing the mask of a comet. And if it really had been constructed, or even altered, then its course through the solar system was not random. It was reconnaissance. Imagine something built long ago. A machine wrapped in frozen layers, scanning worlds as it glided past them, transmitting what it learned into the silence between stars. It wouldn't need to speak. It wouldn't need to reveal itself. It would only need to watch Mars, life lost. Venus, life burned. Jupiter, life shielded. 3 lessons about survival, threaded together by a visitor that learned them in passing. Of course, no one in any observatory or lab could confirm that. Science cannot speak of intention without evidence. And yet, sometimes the absence of noise, the perfect order of something that should be chaotic, becomes its own signal. In the weeks that followed, scientists began quietly comparing data from all 3 planetary corridors, and in that shared geometry, a strange symmetry appeared, as though 3I Atlas had left behind a matching signature in each region, a subtle echo in reflected spectra, the same molecular fingerprint, faint but consistent wherever it passed. Coincidence? Again, perhaps. But in science, coincidences that repeat often become laws. As it drifted past Jupiter's shadow and began its outward journey, the coma started to fade, the brightness diminished, the signal quieted, and one by one the observatories turned their gaze elsewhere. Only the calculations remained, the endless trails of data that now told a story most were too afraid to name. Because when you step back and look at the big picture, you start to see that 3I Atlas wasn't just passing through the solar system. It was studying it, and if it truly was, then it wasn't the first. It was just the one we happened to notice. By late April, the name 3I Atlas had already faded from most headlines. To the casual reader, it was another cosmic curiosity, an icy vagabond from another star, captured briefly in our instruments before vanishing again into darkness. But to those still watching the data, the silence that followed was anything but ordinary. When you place all the orbital projections side by side, something begins to emerge. Something so symmetrical, so unlikely that it starts to resemble intent. It was one astronomer from Prague who first used the term the corridor. He noticed that 3I Atlas's trajectory, if extended both backward and forward in time, mapped perfectly through what he called zones of observation. The first was Mars, our old red neighbor, a world once wet and temperate, now a desert tomb beneath a pink sky. The second, Venus, a planet the same size as Earth but suffocated under its own atmosphere, its surface burning hot enough to melt lead. The third, Jupiter, the system's ancient guardian, whose immense gravity acts as both shield and shepherd, diverting countless asteroids away from Earth, 3 worlds in one line, 3 steps in a silent equation. To some this meant nothing. To others it looked like choreography, a path not chosen by chance but by criteria, like checkpoints on a survey route, designed to sample a system's biological and chemical extremes. When the Prague team ran probability models, the odds of such a route appearing by pure randomness came out below 1 in 200, less than 0.5%, and that was before factoring in the object's inclination and retrograde spin, details that made its precision even more improbable. Still, the public would never know. The data was there, yes, but the story was too strange, too fragile. Scientists wrote around it carefully, as though the wrong word could collapse their credibility. Unusual coincidence, they called it. Unexpected correlation. Nothing more. But behind closed doors, the talk grew bolder. If this path wasn't random, what was it? Was 3I Atlas following the gravitational fields of these planets on purpose, using them as natural waypoints? Or was it simply evidence of a deeper pattern in cosmic dynamics? Something about orbital harmonics we still didn't understand. A young physicist from Kyoto ran a different simulation, one that didn't treat 3I Atlas as a passive comet, but as a body capable of minor course adjustments. He found that with only a few meters per second of controlled acceleration, so small it would be indistinguishable from natural outgassing, the object could have tuned its trajectory perfectly to match the Mars-Venus-Jupiter corridor. 3 short bursts, perfectly timed, could have shaped the entire path. If that were true, it meant 3I Atlas had steering, and if it had steering, it meant it had purpose. Of course, that theory was never published. The Kyoto paper remained a preprint that quietly disappeared weeks later, but screenshots of the models leaked, showing that even a minimal artificial adjustment, tiny, precise, was enough to produce the geometry everyone was seeing. A corridor that wasn't random at all, but navigated. What made the idea even more haunting was its logic. If one wanted to study a planetary system from a safe distance, you wouldn't dive into each world. You would pass near them, close enough for analysis, far enough to remain unseen. You'd move along a path that crosses the regions where signals of life and atmosphere can be measured most clearly. You'd treat the system as a lab, not a destination. Mars, the memory of habitability. Venus, the failure of equilibrium. Jupiter, the shield that makes equilibrium possible. 3 data points that define the boundary between chaos and civilization. A perfect sampling sequence. But what chilled the observers most wasn't the path itself. It was how cleanly 3I Atlas left the system afterward. No gravitational entanglement, no chaotic deflection. It entered quietly, observed, and departed on a line so precise that even Jupiter's massive pull barely altered its trajectory. It was as if it knew exactly how to pass through without disturbing anything. When you watch the simulation in motion, Sun at the center, planets revolving like slow gears, and 3I Atlas threading through them, it feels less like randomness and more like choreography from a distant hand. A dancer moving across a stage, hitting every mark with mathematical grace. No one wanted to say what it looked like, but the whispers began anyway. Maybe this wasn't a comet at all. Maybe it was a surveyor, a quiet traveler that had visited countless systems before ours, tracing corridors through each one, gathering data on planets, atmospheres, and potential signs of life. It would never slow down, never stop, never transmit where we could hear it. It would just glide through, recording, learning, moving on. The idea was beautiful and terrifying at once, because if 3I Atlas really was a surveyor, then we weren't its discovery. We were just another entry in its archive. There was even a strange symmetry to its timing. The object's first detection occurred as Earth's radio leakage peaked, the century mark of our own broadcast age. For the first time in our history, our electromagnetic signature had become noticeable across light years. And right then, a visitor arrived, silent, analytical, following a path that grazed every planet, defining the spectrum of habitability. Was it a coincidence? Almost certainly. But then again, so is lightning finding the tallest tree. The corridor theory never appeared in journals, but it lived on in message boards, data archives, and late-night conversations between researchers who couldn't shake the pattern. Each planet brushed by 3I Atlas revealed a fraction of something larger, a picture that refused to fade even as the object drifted away. Because the truth about patterns is this: once seen, they cannot be unseen, and the corridor it traced still lingers, like a ruler pressed against the solar system, a path that might one day be followed again. If it was a probe, it would come only once in an age, tracing new routes, logging new data, and when it leaves, it doesn't erase its path. It leaves a signature, a geometry written into the dark, waiting for someone curious enough to notice. And we noticed. Maybe that's what matters most, because if we can see the pattern, perhaps the pattern can see us too. The deeper astronomers studied the data, the quieter the conversations became. It wasn't that 3i Atlas was breaking any laws of physics. It wasn't. Every calculation held true. Every observation fit inside the equations that describe how comets move and die. But sometimes, the truth hides not in what is broken, but in what is too perfect. Night after night, telescopes traced the object's steady path across the black. Its acceleration was stable, its brightness curve declined along a line that could have been drawn by hand. Even its rotation, estimated from the modulation in its light, remained strangely constant, almost as if it had been designed to conserve energy, to move without wasting motion. That phrase, without wasting motion, haunted those who ran the simulations, because nature rarely moves that way. Nature is full of inefficiency. It burns, collides, spins, sputters. It dances with chaos. But 3i Atlas moved like something that understood efficiency the way an engineer does. Every turn, every drift seemed optimized, precise, calculated, intentional. When the perihelion passed, the object brightened slightly, but not the way most comets do. There was no violent plume, no sudden jetting of material, just a slow, controlled shimmer, as though the heat of the sun was being managed. It gave off the appearance of natural sublimation, but at a rhythm that defied randomness. A graduate researcher in Chile, unable to sleep, compared the timing of the brightness variations to Venus's orbital resonance. Her notes revealed an unsettling alignment. The peaks coincided roughly with the object's crossing of gravitational nodes linked to both Earth and Venus. It was as though 3i Atlas responded to something, not to light, not to heat, but to position, like a signal adjusting its gain as it moved through the solar system's electromagnetic landscape. The observation was quietly logged, never published, filed under the harmless title, Phase-Correlated Variability Near Resonance Crossings. But those who saw the draft never forgot it, because if that were true, if the changes in brightness weren't random, it meant something else entirely. It meant communication, or at least behavior. Even the chemical outgassing seemed to pulse in sequence. Spectrographs captured faint fluctuations in the ratio of carbon dioxide to cyanogen every 12 hours, matching half of its estimated rotation period. 2 identical peaks per rotation, repeating with clockwork regularity, like a heartbeat too steady to belong to a comet. For a body spinning freely through space, there should have been chaos. Outgassing depends on sunlight and irregular surface features. It should have varied unpredictably. But this was rhythm. This was timing. And rhythm is rarely an accident. Meanwhile, radar mapping from Earth's deep space networks confirmed a subtle anomaly. The surface reflectivity of 3i Atlas was higher than expected for a carbon-rich body. It bounced radar waves almost like polished stone, smooth, dense, reflective. Even stranger, the reflected signal was polarized, meaning the surface was organized at a microscopic level. That's not something we see in natural comets. It's something we see in engineered materials, layered composites, metamaterials, the kind used to guide waves, not scatter them. But no one would call it that, not in public. Instead, the reports use language like unexpected radar albedo behavior and possible surface anisotropy. The truth, dressed carefully in technical restraint. Somewhere deep in the European Space Agency's archives, an internal document labeled ESA Temp 041 described the event more plainly. The scattering characteristics suggest an ordered surface microstructure inconsistent with purely stochastic ice dust aggregation. It was one sentence, dry, clinical, buried in a paragraph about calibration uncertainty. But in that line lived a quiet revolution, because that single observation meant the surface of 3i Atlas might not have been random at all. It might have been built. Imagine for a moment that it was, a surface tuned to reflect certain frequencies, to hide others. A a structure that radiates heat precisely, never overheating, never freezing. A design meant to survive the cold void between stars, not for months, but for millennia. If that's what it was, then it was ancient, far older than our species, perhaps older than Earth's first forests. It had crossed light years, carrying within it a logic we could only guess at. And yet, for all that distance, it still found a path through our solar system, threading the line between planets that told the story of life and extinction. One evening in Hawaii, an astronomer stared at the latest simulation playback, a three-dimensional rendering of 3I Atlas gliding through the orbits of Mars, Venus, and Jupiter. He slowed it down until each day of motion became a frame. The line gleamed faintly, silver against the black background, and when he rotated the view 90 degrees, the curve revealed something unexpected. From a certain angle, the orbit wasn't random at all. It resembled a waveform, a perfect oscillation drawn in space, crest to crest, valley to valley. That pattern, when overlaid on a logarithmic scale, matched the spectral ratio of the object's own chemical emissions. In other words, the shape of its orbit mirrored the frequency of its light. Its motion encoded its signature. Its path was its message. No one could prove it meant anything, of course, but when data starts to rhyme across domains, motion, light, chemistry, scientists listen differently. They may not say the word intelligent, but they start asking questions that only intelligence can answer. Was this a coincidence? Was this a natural harmony, a cosmic rhyme written by chance? Or was it a form of communication so subtle that it required a civilization like ours, curious, newly awake, watching, to even notice? Because perhaps the message was never meant to be heard. Perhaps it was meant to be seen. A geometry drawn across space, encoded in movement, waiting for someone with enough patience to decode it. When 3I Atlas left the region of Jupiter's influence, it began to dim. The data streams slowed. The telescopes moved on. But somewhere, buried in hard drives and research notes, lay petabytes of unexamined correlations, tiny fluctuations, repeating intervals, patterns that no one has yet found time to decode. Maybe someday, someone will. And maybe when they do, they'll find that the object didn't just travel through the solar system, it spoke through it. Not with sound, not with radio, but with motion itself, because in a universe of silence, movement is language. And 3I Atlas, in its quiet perfection, may have been saying something all along. When 3I Atlas finally began its slow climb back toward the dark, most assumed the story was over. The telescopes logged their final readings, the press releases stopped, and the public moved on. But in laboratories and observatories scattered across the world, the data refused to rest. It kept whispering through code, through residuals, through everything that didn't quite fit inside a normal comet's life. A few scientists, quietly, cautiously, began calling it the pattern hypothesis. Others used no name at all, afraid that even labeling it would make it sound like belief instead of observation. They met online, under invitation-only calls, trading datasets that had never been peer-reviewed. If you looked at their time zones, you could almost trace the Earth spinning beneath their sleeplessness. Prague, Tucson, Tokyo, Cape Town, La Palma, every one of them staring at the same orbit that made too much sense. The first to speak plainly was an orbital dynamicist from Chile. She wrote, in an encrypted forum post that would later be deleted, "If this object is natural, it's the most statistically efficient piece of chaos ever recorded." The sentence circulated in screenshots, stripped of its name, dissected by those who needed permission to wonder. Because the evidence, though fragile, kept multiplying. It wasn't just the geometry anymore. It was the way 3I Atlas had anticipated the gravitational pulls it would encounter, threading every curve like a seasoned pilot through turbulence. Most comets lose fragments when they pass close to a planet's field. They wobble, spin, drift off course. 3I Atlas didn't. Its vector hardly shifted at all. It adjusted, almost invisibly, holding to a path that seemed less reactive than predictive, as though it knew the solar system better than we did. One group from the University of Toronto tried to model this precision using purely natural assumptions. They added every known perturbation: solar wind pressure, outgassing jets, magnetic drag, micrometeorite impacts. And still, the simulated trajectories diverged. Only when they introduced a minute corrective force, less than 0.01 newtons, barely the weight of a falling leaf, did the model match reality. A force that appeared again and again, always opposite to expected drift, always restoring the same course. They called it non-random residual acceleration. The kind of phrase that sounds safe until you realize it's just a technical way of saying steering. No one wanted that word in print, but it lingered in footnotes, in code comments, in late-night whispers over coffee. If the numbers were right, 3i Atlas was not merely coasting through gravity, it was navigating it. Then came a stranger revelation. A data analyst in Canberra compared the object's trajectory to historical records of near-Earth interstellar visitors. He found that if you mirrored 3i Atlas's path along the ecliptic plane, it intersected, within margin, with the outbound route of 1i Oumuamua discovered years before. Two separate objects, separated by time and distance, tracing nearly symmetrical arcs through the same celestial corridor. If drawn together, they formed a single waveform, entry and exit, like inhale and exhale. No one dared suggest the two were related, but the pattern was there, waiting, glowing faintly behind probability. By now, every serious researcher had taken sides. Half insisted it was coincidence stacked upon coincidence. The other half had stopped using the word coincidence at all. They started talking about protocols. If an ancient survey mechanism existed, how would it work? What would it measure? Would it leave behind signals or simply movement? An astrophysicist from Rome proposed a quiet, unsettling thought. He said, "Maybe we're thinking in the wrong direction. Maybe these aren't messages to us. Maybe they're messages for each other." If he was right, then the solar system was not the audience. It was the canvas. Objects like 3i Atlas could have been leaving imprints, geometric patterns invisible until intelligence evolved that could read them. A language written in orbits, stretched across centuries. That idea circulated for weeks, hidden in research chat logs. Some called it madness, others called it inevitable. Because once you begin to see pattern in motion, you begin to wonder if the universe itself is communicating. Slowly, methodically, through the trajectories of stones and ice. By now, the probes and telescopes could no longer see 3i Atlas directly. It had slipped past the range of strong signal return, fading into the thin echo of reflected sunlight. But the data it left behind continued to hum in archives. Small deviations, repeating intervals, correlations no one could dismiss entirely. Even the most skeptical scientists began using softer language. Words like anomalous coherence, structured dynamical evolution, or simply unknown modulation. It was easier that way, to talk about the evidence without touching the implication. Because the implication was heavy, it meant that something, somewhere, might be using physics itself as a communication medium. Not radio, not light, but motion. A few journalists tried to chase the story, but none could get quotes on record. Everyone with access to the data was too careful, too aware of how fragile credibility could be, so the idea stayed in the dark, just like the object that started it. And yet, the public didn't need to be told. People could feel it. Across forums, podcasts, and late-night videos, the story resurfaced in another form. The notion that maybe, long before we learned to look outward, something else had already looked inward. The scientists went quiet, but the silence itself became an answer. Because in science, denial is loud. But uncertainty, that's whisper quiet, and every whisper pointed to the same unspeakable idea. Atlas might not have been wandering. It might have been returning to a corridor already traveled, returning to measure what had changed, returning to see what had begun to watch back. By the time 3i Atlas disappeared into the outer dark, the story had fractured into two worlds. In one, the official one, it was simply an interstellar comet whose oddities could be ironed smooth with better data. In the other, the quiet world of those who couldn't stop thinking, it had become a mirror held up to something larger than science itself. No one said alien. No one needed to. The implication was like static humming just beyond hearing, impossible to prove, impossible to silence. Weeks after its final observation, a private working group formed across a half-dozen observatories. They called themselves the Continuum. Their only rule, no speculation, only pattern. If something repeated, it mattered. If it didn't, it was noise. They began comparing every known interstellar visitor, y Oumuamua, 2i Borisov, and now 3i Atlas, stacking orbital planes, inclinations, velocities, entry points. When those parameters were projected on a galactic map, the three orbits looked random, until you turned the model 90 degrees. From that angle, the lines converged. Each path intersected within a narrow band above the galactic plane, as if these objects had all come from a shared corridor cutting through the local arm of the Milky Way. The discovery wasn't public. It lived inside encrypted drives and late-night calls that began with disclaimers and ended with silence. Because if the corridor was real, then we weren't looking at isolated wanderers. We were seeing traffic. The idea was as old as fear itself, that something moves between the stars not once, not rarely, but routinely, and that we had only just developed eyes sharp enough to glimpse it. If so, the solar system wasn't unique. It was simply one waypoint among millions. The continuum simulations suggested an even stranger pattern. Each interstellar trajectory, when extended backward, aligned not toward a star, but toward the void, the empty region between stellar neighborhoods, where almost nothing exists, an improbable origin, unless the objects weren't departing from a home star at all, unless they were departing from each other. One of the younger researchers wrote in her notes, "They could be listening posts, moving in formation so vast that we only see single points of it at a time." The others ignored the comment, but it hung there, uncomfortably rational. Because when you zoom out far enough, what looked like chance began to resemble architecture, an arrangement too wide for human scale, too steady for natural drift. Back on Earth, a different kind of pattern emerged. In the weeks surrounding 3I Atlas's perihelion, several deep space radio arrays recorded unexplained bursts of narrowband noise. Each lasted less than a second, too brief for a transmission, too structured for static. They came from different points in the sky, none aligned with 3I Atlas directly, yet all within the time frame of its inner system passage. The official explanation was terrestrial interference. It usually is, but buried in the logs was one detail that didn't fit. Each burst occurred when the object crossed a planet's orbital plane. Mars, then Venus, then Jupiter. 3 worlds, 3 alignments, 3 bursts. Coincidence? Almost certainly. But coincidences stacked high enough begin to form stairs. The continuum analyzed the waveforms anyway. When they slowed the signals down by a factor of 1,000, the bursts revealed structure, symmetry between rise and decay, amplitude ratios that mirrored orbital eccentricities of the very planets the object had passed. The pattern folded in on itself like a reflection in glass. If it was random, it was beautifully random. No one published the result. It would have drowned in scrutiny. Instead, they wrote private notes, shared encrypted plots, and told themselves it was an artifact of data compression. But in quiet moments, when the screens went dark, every one of them wondered the same thing. What if we were never meant to hear it as sound? What if it was meant to be seen? A signature left in electromagnetic space, a trace for the next observer to find. The thought was terrifying in its calmness, because it implied observation without contact, understanding without conversation. It implied watchers, maybe not creatures, maybe not machines, maybe something older than both. Processes that move through galaxies like surveyors through forests, leaving markers carved in the gravity of stars. And maybe we were one of those markers now. After 3I Atlas left, the solar system didn't return to normal. For months, background noise levels in deep space monitoring arrays remained slightly elevated, just enough to notice, not enough to explain. The anomaly persisted, steady and indifferent, like an echo with no source. Eventually, the data tapered off. Telescopes pointed elsewhere. Funding shifted. The continuum disbanded. But the files remained, sealed under project codes and anonymous authorship, waiting for the next visitor. Because if 3I Atlas was part of a network, if these paths are the threads of a map, then another is coming. The pattern demands it. The rhythm always completes its cycle. And when it does, we may finally learn whether we were the observers or the observed. Silence in astronomy is rarely empty. It's filled with data, static, cosmic background, whispering particles and photons too tired to carry meaning. But the silence that followed 3I Atlas felt different. It wasn't the absence of noise. It was the absence of response. In the months after its departure, a few remaining observers continued watching the region where its faint trail had vanished. Most nights, the sky offered nothing, just starlight, the slow drift of dust, and the faint radio hum of the Milky Way. But every so often, a flicker appeared, a spike in frequency, a sudden change in background density, a pulse of electromagnetic interference that shouldn't have been there. Tiny things, almost imaginary, the kind of anomalies that disappear the moment you try to measure them. But they happened again and again, always near the same coordinates where 3i Atlas had passed. A few dismissed it as sensor drift. Some blamed solar activity, but one group of signal analysts from California noticed a strange pattern. Each pulse carried a delay consistent with reflection, as though something out there was bouncing signals back at us, faintly and with perfect timing. When they mapped the time intervals between pulses, the spacing wasn't random. It followed the same ratio as the distances between Mars, Venus, and Jupiter. 3 numbers, 3 echoes, 3 worlds, and one path linking them. If it was interference, it was hauntingly poetic interference. They tried to reconstruct the signal at full bandwidth. The more they filtered it, the clearer the pattern became. Not a message, not words, but order. A pulse, a pause, another pulse, then a long silence. Repeating stable cold. It sounded like nothing, but looked like intention. No one could locate a source. No probe, no spacecraft, no asteroid debris. Just empty space, holding the ghost of a pattern too clean for chaos. That's when an old mathematician from the continuum spoke up. He had spent decades studying orbital resonances, the way planets tug at one another like notes in a chord. He pointed out something everyone had overlooked. 3i Atlas's path didn't just intersect Mars, Venus, and Jupiter. It did so in resonance. Their orbital periods formed a simple integer relationship, a 2-3-5 ratio, the kind of harmonic progression musicians and physicists both recognize instinctively. In that ratio, he said, was balance, the universal signature of efficiency, and perhaps of recognition. Because if you wanted to announce your presence without language, without sound, without technology, you'd use mathematics. You'd use motion itself. You'd move through worlds in perfect proportion, carving ratios into the very structure of a solar system, a signature anyone could find if they ever learned to see the pattern. No one wanted to admit how elegant it was, how much it felt like design. The theory spread quietly, passed through whispered conferences, encoded in harmless equations. They called it the resonance hypothesis. It didn't claim to prove anything. It only suggested that maybe, long ago, an intelligence had left behind a language written in orbits. Not for us, but for anyone who came after. A cosmic ledger of civilization, updated every few million years by passing messengers like 3i Atlas. The idea was beautiful, terrifying, and impossible to test. Yet once seen, it refused to fade. At night, the astronomers who had chased its trail began to dream of motion, of a quiet geometry unfolding around them, planets like notes, space itself as sheet music, and somewhere beyond their reach, another traveler, another piece of the song, moving between stars on a timescale far older than thought. In a quiet observatory in Japan, one of them recorded a final log before resigning. Her voice was calm, her tone almost reverent. If there is design here, it's not the kind we imagine. It's not curiosity, it's continuity. Something moves through space not to explore but to remember, to keep record of what has lived and died. After that, her telescope was decommissioned, her files archived. No one followed up, but those words stayed, because they hinted at something deeper than technology, a cosmic act of memory. Perhaps that's what 3i Atlas really was. Not a machine, not a messenger, but a mirror, moving through time to preserve a story we don't yet know we're telling. A fragment of awareness left adrift forever, recording what light touches what world. The universe doesn't speak. It arranges, it aligns, it builds meaning from silence. And if you listen closely enough, in the intervals between signals, you can almost hear it breathe.